Okay, Algebra 2, this is Trig video number 2. Topics for today's discussion will be degrees, radians, and revolutions. Also, types of rotations, positive and negative, as well as an introductory discussion on the unit circle. So, let's get into the details of rotations first. First of all, rotations are positive or negative, and positive goes in the counterclockwise direction while negative goes in the clockwise direction. 0 degrees is always found in the positive direction of the x-axis. So that would be 0 degrees out this direction, and then that's... So when they say draw a 30-degree angle, obviously that's positive. All right, you got your axes. The first side that you need to draw is always out towards this way, and that is called the initial side. And then you measure the 30-degree angle, right? Something like this, because from here to the top is 90 degrees. This is called the terminal side. And I want you to put an arrow in between so that I know which direction you're going. So you've got your initial side and your terminal side and your direction, and that's an approximately 30-degree angle. So what about a negative 120-degree angle? Okay, so this is 0 degrees. This is negative 90 degrees. If you're going in the negative direction, that would be down. This would be negative 180 degrees. So we've got our initial side, right? And we've gone all the way to 90, and then 30 degrees past that, so something out here. There's your terminal side, and draw the arrow so that I know which way you're headed. So there is your negative 120-degree angle. Now the next thing you need to know is how to convert between these 3 units of measurement. We've got degrees, which you're very familiar with, revolutions, which isn't too uncommon to you since you it's a fairly common unit to use. And then another one that's not common at all for you, but it's the distance around the edge, the edge of the circle, based upon the circumference formula. These units are called radians. And 2 pi radians, which would be the circumference of a circle of size 1, of radius 1. Okay, so circumference of circle with radius 1. That's where we get that from. Those are all equal measurements. Now 180 degrees, that's equal to only 1 pi radians. That would be a reduced version of the 360 equals 2 pi version. Now, I might ask you to fill in this chart. And I might give you a degree and ask you to find the others. So we'll start with 45 degrees. And we're going to convert it to revolutions. Well, 45 degrees. This is the good old factor label method that you've seen in maybe in a science class. You want the degree units to cancel, but we want revolution units to be left. So 1 revolution is equal to 360 degrees. We need to reduce that. So 360, 45 happens to go in evenly, nice, 8 times. So this one reduces fairly quickly. to 1 out of 8 revolutions. Notice that the degree units canceled out. Well, what about radians? If you want to convert that to radians, you start with your 45 degrees. 180 degrees is equal to pi radians. That comes from the unit conversion that you wrote down at the top. The degree units cancel. 45 happens to go into 180 nicely. Always check with your calculator. It goes in nicely 4 times. So this is pi over 4 radians. So we could fill out our chart 1 over 8 and pi over 4 with those values that we found. So we've got that one down. Next we have 1/12 of a revolution, and we're going to switch it to degrees. So 1/12 of a revolution, and we want to multiply that. We want to get rid of revolutions, and so we're going to convert this to degrees. The revolution units will cancel. So I need to see how many times 12 goes into 360. Well, I know 12 goes into 36 3 times, and so that's going to leave me with 30 degrees. Well, what about 1/12 of a revolution being changed into radians? Okay, we want the revolution units to cancel, but that's 2 pi radians. So I can easily reduce that, right? The revolution units cancel. 2 goes into 12 6 times, so this is pi over 6 radians. So I can fill those values in 30 degrees and pi over 6 radians. Last but not least, we've got pi over 2 radians, and we want to convert it to the others. We will start with pi over 2 being radians, being converted to revolutions. Okay, 1 revolution is equal to 2 pi radians. So what cancels out? The radians cancel out. Oh, look, the pi's cancel out also, leaving me with 1, and 2 times 2 is 4. 1/4 of a revolution. And then pi over 2 radians. We want to convert that to revolutions, or degrees, I should say. So pi radians is equal to 180 degrees. The radian units cancel out, the pi's cancel out. 2 goes into 180 90 times, so it's 90 degrees. So that completes our table. We've got our table of values all figured out, and you might have to do that on a quiz or test. Okay, what about the unit circle? All right, that is a circle of radius 1. Every point on that circle has an x value and a y value. Now, I've got x here and I've got y here. In order to get to that location, you have to go x units to the right and y units up. There is an angle of rotation inside here. We'll call it angle theta. Now what I need to know is the relationship between theta and x and y. Oops, wrong direction. Well, I know that the cosine of theta is equal to adjacent over hypotenuse. That's x over 1. Well, that's a fancy way to say x. What about the sine of theta? The sine of theta would be opposite over hypotenuse. So now you know the relationship between x and y and theta. X is the cosine of theta and y is the sine of theta. So every point on the unit circle can be easily calculated as long as you know the cosine goes with x and the sine goes with y. So I'm going to ask you questions like, what's the cosine of 30 degrees? Well, there's the angle for 30 degrees. I want to know the x value, the distance from here to here. Well, folks, isn't this a 30, 60, 90 right triangle? So in class on Monday, we're going to discuss this. How do we find this if you know that this is 1? So be prepared for that discussion. If this is the hypotenuse, how do I go back to the short leg? Well, if you remember what we did with special right triangles, don't you cut it in half? So half of 1 is 1/2. And how do you go from the short leg to the long leg? Don't you multiply it by radical 3? So that would be 1/2 times radical 3, and we more commonly at parties refer to it as radical 3 over 2. You know, when you're having those discussions with people, you know, you want to sound intelligent. You don't want to say radical 3 times 1/2. You want to say radical 3 over 2, right? Because then you'll be cool. I'm also going to ask you things like the sine of 45 degrees. Well, think about that. 45 degrees. Now, I'll redraw it so that it's not so difficult to see because I've got another triangle there. But we have a triangle with a 45-degree angle and a hypotenuse of 1. Now, remember, how do you go from the hypotenuse back to either one of the legs? Because I'm looking for sine, I'm looking for the y value. So that would be this side right here. Don't you take that and divide by the square root of 2 instead of multiplying? Now, don't ever say 1 over radical 2 at parties because people are going to think you're weird. You want to rationalize that and then quote them radical 2 over 2. Then they will go, ooh, you know, it's because you're smart. So, we've got all of these x values and y values we're going to start talking about in class, but it's all based on these 30, 60, 90 right triangles and these 45, 45, 90 right triangles, except for the basic corners. Let me talk about the kindergarten points on the unit circle. I call them the kindergarten points because they're the most obvious ones. Whoops, gotta have it on screen. So this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. And this is the point 0, -1. And I'm going to ask you things like, what's the cosine of 90 degrees? Well, you go to that place on the circle and you tell me what the x value is. 0. What's the sine of 180 degrees? You go to that place on the circle, which is 180 is over here, right? Remember, it's 0, 90, 180, 270. And you tell me what the y value is in this case, because they asked me for sine. That's also 0. What about the sine of 270 degrees? Well, you find 270 degrees, check the y value, looks like -1. Not too difficult to do on the kindergarten points to go around the circle and identify the sines and the cosines, because they're x's or y's and they're very obvious numbers. We're going to do the stuff with the triangles when you get to class on Monday. See ya.